If you want to witness what truly harsh conditions look like, arid, barren, and seemingly lifeless, look no further than the vast stretches of northern and northwestern China. Regions like Inner Mongolia and Xinjiang are dominated by stony deserts, shifting sand dunes, dry grasslands, and semi-deserts that seem hostile to anything that breathes. These are textbook examples of land barely fit for life. But the startling part is that many of these lands didn't become barren on their own. Human activity played a massive role. Rapid agricultural expansion, relentless industrial growth, deforestation, and overgrazing have all contributed to one of China's most pressing environmental issues, desertification. And unfortunately, this process isn't slowing down. The Chinese government has responded with massive reforestation and land restoration efforts, including the well-known Green Great Wall project that involves planting billions of trees. But there's also a lesser-known strategy at play, one that involves a rare and once-extinct species of wild horse. These are Przewalski's horses, named after Russian explorer Nikolai Przewalski. They're not just any wild horse, they're the last truly wild subspecies in existence, never domesticated by humans. Unlike the horses we're familiar with, these animals are shorter, stockier, and have a distinctive upright mane with no forelock. More importantly, they're survivors, built by nature to withstand the extreme climate of Central Asia. Historically, Przewalski's horses roamed the vast steppes of Mongolia, Kazakhstan, and parts of China. They thrived in tough environments, enduring brutal winters, scorching summers, and limited vegetation. But in the late 19th century, their population began to plummet. Several factors drove them to the edge of extinction. Hunting was a major issue. Though their meat wasn't considered a delicacy, it was a valuable source of protein, especially during famines or wars. Since the horses move in open landscapes, they were easy targets. As firearms became more common, their chances of survival dropped sharply. At the same time, the growth of livestock farming pushed them out. Humans brought in sheep, goats, and domesticated horses, all of which grazed the same grasslands. These domestic animals consumed vast quantities of vegetation, polluted water sources, and introduced diseases. Even worse, domestic horses interbred with the wild ones, producing hybrids that were less fit for survival. Meanwhile, human development carved up the landscape. Roads, farms, fences, and canals cut through once continuous grasslands. Migration routes were blocked, and these wild horses, whose survival depended on movement and space, were confined to shrinking pockets of land. The ecosystem was breaking down fast. Overgrazing, deforestation, and poor water management accelerated the spread of deserts. And as the vegetation disappeared, so did the animals that depended on it, herbivores, predators, and finally, the horses themselves. By the mid-20th century, wild Przewalski's horses were in serious trouble. Conservationists were aware of the situation, and in 1959, they established the International Stud Book to track the genetics and pedigrees of horses in captivity. But it was too late to save the wild populations. By the late 1960s, sightings in the wild had ceased. Researchers scoured the steppes for signs, hoof prints, dung, anything, but found nothing. The species was declared extinct in the wild. The only surviving individuals were those in zoos, descended from a handful of horses captured decades earlier. But this small, fragile population held the key to something remarkable: a second chance. With the horses gone, ecosystems began to collapse even further. Vegetation didn't recover as expected. Sand dunes advanced. Other animals left. It turned out Przewalski's horses weren't just bystanders, they were essential players in maintaining ecological balance. That realization sparked a global mission to bring the species back. And China, where much of their historic range was located, stepped forward. In 1986, China launched the Xinjiang Wild Horse Breeding Center, right in the heart of a barren, desertifying region. It wasn't exactly a promising environment, but that's what made it the perfect testing ground. To restore the land, they needed to restore its original inhabitants. With no wild horses left, China turned to international partners. Zoos in the UK, Germany, and the United States contributed 8 stallions and 10 mares. These animals formed the foundation of a reintroduction program unlike any other. In 1987, China imported 18 more horses, carefully selected for genetic diversity. These horses weren't released right away. Scientists kept them in large, semi-wild enclosures, allowing them to relearn essential survival skills, finding food, locating water, avoiding predators. Slowly but surely, they were being re-wilded. Finally, in 2001, the first group was released into the Kalamali Nature Reserve in the Yungar Basin. Since then, China has released additional groups, including the 18th batch in May 2024, which included 7 stallions and 11 mares. That brings the total number of reintroduced wild horses in Xinjiang to 146. It may not seem like much, but the ecological impact is profound. Let's start with something basic: manure. A single Przewalski's horse eats about 12 to 15 pounds of grass and other plants per day. Along with that, they consume seeds. When they defecate, they deposit not just waste but nutrients and seeds, essentially planting life across the landscape. In this way, they help revive areas where vegetation has vanished. Now scale that up. Hundreds of horses moving across the land, each one dispersing seeds, fertilizing soil, and creating microhabitats. Some of the seeds won't take root, but many will. And over time, this cycle transforms barren soil into living ground. Even better, their movement across large areas helps maintain biodiversity. Unlike sheep or cattle that remain in one spot and overgraze the land, Przewalski's horses are always on the move. They eat a little here, a little there. This creates what scientists call a patchy landscape: tall grass in some spots, short grass in others. That diversity of vegetation is crucial. Some animals prefer tall grasses for cover. Others, like certain birds and rodents, need short grass. Some species require both. This uneven terrain provides something for everyone, and Przewalski's horses are the reason it exists. Another important point: unlike sheep, which rip grass out at the roots, these horses bite it off cleanly. That allows plants to regrow more quickly. Their grazing is sustainable, not destructive. Of course, not every horse survives. Young and weak individuals may fall prey to wolves. At the moment, the horse population in China is still small and doesn't attract many predators. But as it grows, wolves and other carnivores may return, adding another layer of complexity and balance to the ecosystem. Wolves, too, are ecosystem engineers. They help control populations and create space for smaller species. So how far has China come? As of 2024, the total population, including captive and re-wilded individuals, in Xinjiang has reached 534. That's an incredible achievement for a species once considered extinct in the wild. But China isn't stopping there. In Gansu Province, at a breeding and research center in Wuwei, additional efforts are underway. Scientists are carefully developing smaller, genetically diverse herds that can later be released. It's a long-term strategy focused on stability and sustainability. These efforts are also helping neighboring countries. Mongolia and Kazakhstan, which were once part of the wild horse's natural range, are both part of the reintroduction movement. Mongolia, in particular, has seen major success. In 1992, the first horses, transported from European zoos, arrived at Hustai National Park. This wasn't a small operation. Zoologists from Germany, the Netherlands, the Czech Republic, and Switzerland were involved. The Prague Zoo played a leading role and still manages the International Stud Book. Military planes were used to transport the animals, a testament to the seriousness of the mission. Over time, more regions joined the effort, including Komiantau and the Great Gobi Reserve. Today, there are over 1,000 wild horses roaming Mongolia, completely free. No fences, no feeding stations. In Kazakhstan, progress has been slower. In 2003, 10 horses were released into Altan Emel National Park. But by 2015, the population had only grown to 14. Recognizing the need for a bigger push, Kazakhstan launched the Return of the Wild Horses project in 2024 with help from the Prague Zoo and other international partners. Perhaps the most unexpected chapter of this story comes from Ukraine and Belarus. In 1998, a herd of 31 Przewalski's horses was released into the Chernobyl Exclusion Zone, CEZ, a place abandoned by humans after the 1986 nuclear disaster. Nobody expected much. The area had radioactive soil, abandoned buildings, and no infrastructure. But something incredible happened. The horses thrived. They grazed, reproduced, and spread throughout the zone. Despite the risks, they helped stabilize the ecosystem by preventing overgrowth and supporting biodiversity. By 2003, there were 67 horses in the Ukrainian section of the CEZ. By 2018, the number had doubled. As of 2023, estimates suggest there are 180 to 200 horses in the zone, possibly up to 300 if you include the Belarusian side. These animals, once thought extinct in the wild, are now symbols of resilience. They've returned to China, Mongolia, Kazakhstan, and even radioactive Chernobyl, not just surviving, but healing the land as they go. It's a quiet comeback, hoofprint by hoofprint. And in the face of desertification, it may be exactly the kind of natural engineering the world needs. Less than 20 years ago, a remote island in the Southern Ocean became the stage for one of the most dramatic conservation stories in modern history. It all started with a simple but disastrous mistake, the arrival of rats and mice. What followed was an environmental catastrophe few could have predicted. These rodents, left unchecked, unleashed a domino effect that nearly destroyed the island's fragile ecosystem. The place was Macquarie Island, often called the island that time forgot. Located between Australia and Antarctica, this narrow strip of land once flourished with life. Giant elephant seals sprawled across its beaches, while hundreds of thousands of royal penguins waddled ashore each breeding season. Further inland, vast meadows of tussa grass and towering megaherbs gave the landscape a prehistoric feel. The animals here had evolved in isolation for thousands of years without natural predators. Their behaviors reflected this innocence. Petrels, for example, nested in underground burrows with no fear of attack. But that isolation also made the island vulnerable. When seal hunters arrived in the early 1800s, they brought with them uninvited guests, rats and mice. These small stowaways quickly found paradise. No predators, plenty of food, and endless places to hide. They multiplied rapidly and began preying on the island's native species. Bird eggs, chicks, and even adult birds were devoured. Seeds and sprouts were eaten before they had a chance to grow. Insects disappeared. The finely balanced ecosystem began to unravel. In an attempt to control the rodent outbreak, cats were introduced. But rather than focusing on rats and mice, the cats turned to easier prey, defenseless seabirds that had never learned to fear them. The carnage was staggering. Cats killed tens of thousands of birds each year, hunting not just for food but for sport. Entire species vanished. The Macquarie Island rail and the colorful island parakeet were both lost forever. By the mid-1900s, a new threat emerged. In 1878, rabbits were introduced to provide emergency food for shipwrecked sailors. Left without predators, they bred uncontrollably. By 1968, more than 100,000 rabbits were chewing their way through the island's vegetation. They stripped the land of its iconic plants, digging into the soil when the greenery was gone. Hillsides that had once been lush collapsed into dust. The final straw came in 2006 when a massive landslide buried hundreds of king penguins in Lusitania Bay. Years of erosion caused by rabbit grazing had destabilized the terrain. What had once been one of the island's most important penguin colonies was now a disaster zone. Scientists visiting the island were stunned. A place that had once brimmed with life was now a wasteland. Some of Macquarie's rarest plants existed only behind fences. Several bird species teetered on the brink of extinction. The chain of destruction had spiraled beyond control. Cats introduced to kill rats had decimated birds instead. Rabbits introduced as a food source had eaten the island bare. The rats and mice that started it all continued to thrive, unchecked by any natural predator. What scientists were witnessing wasn't just ecological damage, it was a full-blown trophic cascade where a disruption at one level of the food web sent shockwaves through every other part. By 2007, Macquarie Island had become a global cautionary tale. But it also became the site of one of the most ambitious conservation projects ever attempted. The goal? Total eradication of every invasive mammal, every rat, mouse, and rabbit. Not a few, not most, all of them. It was a massive undertaking with an estimated cost of over $24 million. The plan involved a combination of biological warfare, chemical intervention, and canine precision. First came the virus, rabbit hemorrhagic disease, delivered via carrot bait in the island's worst affected areas. It worked fast. Within months, the rabbit population plummeted. Then, helicopters blanketed the island with over 300 tons of poison pellets designed to eliminate rats and mice. But poison alone wasn't enough. To protect scavenging birds from eating tainted carcasses, teams of workers spread out across the island, collecting thousands of dead animals by hand. Still, the biggest danger wasn't what they could see, it was what they couldn't. Even a single surviving rat or rabbit could restart the cycle. That's when the elite team arrived, 12 specially trained detection dogs and their handlers. These were not ordinary animals. They had been trained for months to sniff out the faintest traces of rodents. One dog, a Labrador named Wags, became the face of the mission. With handler Melissa Houghton, Wags explored every corner of the island, from steep cliffs to underground burrows, searching for signs of life. The dogs covered more than 90,000 kilometers, equivalent to circling the Earth twice. Every positive scent led to an investigation. Every cleared area was marked. And in late 2011, the breakthrough came. Deep in a remote valley, Wags found the last surviving rabbits, a mother and her young. The discovery was a relief, but also a wake-up call. If one family had survived this long, others could be hiding too. So the search continued. More dogs were brought in. Teams worked day and night. By 2013, months had passed with no new detections. Still, no one wanted to celebrate too soon. After all, it had taken nearly 2 centuries to cause this much damage. Restoring the island would require absolute certainty. On April 8, 2014, Macquarie Island was officially declared pest-free. For the first time since 1810, not a single invasive mammal remained. It was a milestone in conservation history. But the question remained, could nature recover? The answer came faster than anyone expected. Almost immediately, plants began returning. Seeds that had been dormant for decades began sprouting. Tussock grass grew tall again, reclaiming hillsides once stripped bare. The megaherbs, like Macquarie cabbage, began spreading without fences. Even the 2 orchid species, once confined to tiny protected zones, were found growing wild across the island. The recovery wasn't just botanical. The birds returned too. White-headed petrels rebounded. Blue and gray petrels, thought lost from the island, established new colonies. Penguin populations rose. As the birds came back, they brought nutrients with them. Guano enriched the soil, helping plants grow faster. More plants meant better cover for nests, which meant more birds. The island entered a positive feedback loop of rebirth. By 2024, 10 years after the pest-free declaration, the transformation was breathtaking. Scientists found that some bird populations were growing by more than 10% each year. Tussock grass was so dense and tall that researchers had to hack their way through it. Beneath the greenery, penguins carved tunnels like secret highways. And the once rare plants were thriving in places they hadn't been seen in generations. Perhaps most astonishing of all was how quickly it all happened. Experts had predicted it would take up to 50 years for the island to recover. But within a single decade, nature had roared back. Macquarie Island, once a symbol of environmental collapse, had become a beacon of hope for conservation around the world. Inspired by this success, countries like New Zealand have begun applying the same eradication strategies to other islands, including larger, more populated ones like Ricura, Stewart Island. What began as a local crisis is now guiding global policy. Still, the island's safety remains fragile. Today, Macquarie Island is protected by strict biosecurity. Every ship is inspected. Every backpack, boot, and crate is scrubbed and searched. Specially trained dogs scan cargo for the faintest trace of invasive species. The cost of prevention, scientists say, is nothing compared to the cost of letting history repeat itself. The story of Macquarie Island is one of catastrophe and redemption. It proves that even the worst environmental mistakes can be corrected. That humans, while capable of great destruction, are also capable of great repair. So what can we learn from Macquarie Island? That when we act boldly, patiently, and with science as our guide, we can give nature a second chance. And sometimes that's all it needs.